Okay, so for these set of problems, we've been instructed to evaluate for 1, 2, 3, 4, 5 problems. So for A, I started by acknowledging that the square root of 64 is a perfect square that can be square rooted by 8. And I spot the negative so that after square rooting this, the negative is going to be redistributed, is the way I would say it. And because the negative is on the outside of the square root, it doesn't really impact my square root because it's on the outside. So we're just going to come back to this at the end. So the square root of 64 is 8, and we're going to redistribute the negative, so it's being negative 8. And that was pretty straightforward. So, and the pro tip that I would give for this one is to know a few perfect squares like in your back pocket, so you don't spend a lot of time on easy problems like this, especially during a final. So for B, we have the square root. We have to solve the square root of negative 16, and having a negative radicand is not possible, so there's no real solution. Whenever you see a negative radicand, there should be like a red flag in your head that there's no real solution. And the reason why is because a negative times a negative is going to equal positive. Anything times itself, whether it's negative or positive, is going to result in a positive. Therefore, a negative radicand is not possible. So there's no real solution. And for C, the answer is pretty straightforward. It's just going to be 0, because 0 times itself equals 0. So if you were to take the square root, therefore the square root of 0 is always 0. And this one kind of tripped me up a little because I'm like, I don't know, it just seemed too easy. So something you can ask yourself is what times itself gets you the radicand inside the square root. Okay, now this one is a square root times a square root. Could also be rewritten as 27 times 12 within the square root, which, let's see, 27 times 12, 4, 5, 7, when multiplied, it's going to get you 324. And another way you can do this is just by like expanding each one and see if they have any pairs within each other. For example, 27 could be distributed or expanded into 3 times 3 times 3. And then 12 can be distributed by 3 times 2 times 2. So I noticed that there's, if you pair everything up, there's 3 pairs. Which means that if you were to do 3 times 3 times 2, that would get you 18. And because there's perfect pairs within the square root, we can take the square root out. So the answer is 18. And for this one, the way I started it is by expanding the expression. So this is the same thing as this. And that's when I saw, oh, essentially it's a negative times a negative, which is just going to give me positives. And the square root times the square root is going to eliminate these square roots. So the answer is 21. It's not 21 times 21, it's just 21. And yeah, thank you for watching.